We'll punch it in, natural log 4.6 divided by 14.7 and divided by, don't forget parentheses around the denominator, negative 0.21, and we'll see it's 5.53 miles approximately high. Okay, next question.
Can I do a problem like 16?
A problem like 16, yes. 16. 13, 14, 15, 16. Yes. This is page, I'm sorry, it's a section, never mind. Here it is. Let's say number 10 on page 616. Of course, it's chapter 5 I meant to say. On 616. Y less than or equal to 1 minus x squared, and x squared plus y squared less than or equal to 9. Since a few weeks back, maybe 6 weeks back, when this class started at 12, remember I told you that I'm losing my voice after the third class. So my apologies. Okay, this is a system of nonlinear inequalities. So then, remember, I can only present the solution by graphing it. So I have to start with the equation. And I know what this is, because I already pictured the graph, right? It's x squared, right? X squared reflected and up 1. Where does it cross? So it's x squared reflected up 1. Where does it cross? Of course at 1, 0, 1. And where else? Yes. Done. So now you know so much that you don't really need to, since it's solid, I mean, you know what I mean. It has an equal symbol. It has to be solid. And this is just the equation. So 1, negative 1, 1. So this is only y equals 1 minus x squared. Now I check with the origin, so I'm checking the interior. So 0, 0, 0 less than or equal to 1. If you say okay, then I'll shade in the inside. If you say not okay, then I have to shade in the outside. You will say okay? So the graph is this. The inside is this. Now I need to graph the x squared plus y squared equals 9. It's a circle. Where is the center? Perfect. And how big is the radius? Excellent. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Solid or not? I'm not going to get a perfect graph. My apologies. My unit is all over the place, but it's good enough. Now I realize that I have to extend this graph. Okay. So now I see that the circle divides the entire plane into the inside and the outside. So I plug in 0, 0. I like that. So 0 less than or equal to 9. If you say yes, I'll shade in the inside. If you say no, I'll have to shade like rays of the sun rays. So I have to shade in the inside. So the circle, just the graph of the circle is x squared plus y squared equals 9. But the inside is x squared plus y squared less than or equal to 9. So now if the blue and brown do not overlap, I'll say no solution, it's done. But if the brown region of the circle and the blue region of this the parabola, if there is an overlap, then I'll say that's it. That's where the solutions will be found. I did start this. I saw myself starting it. Yeah. Yes? So everything on this curve, everything on this curve, everything on this curve, and everything in between. So this is both. Good. Next one.
15? 15. That one's a circle.
15. Yeah, we did one at the beginning, but if you want to choose another, we can. We started with one similar, but we can, like this one. So the nonlinear inequality, the nonlinear equations. You can use substitution here or elimination. Here, you have no choice, just substitution. But we can choose another. Is that a yes? Yes? Very good. One that works with both, or one that works with a particular method?
The circle. The equals are
Okay. Not sure exactly what you meant by the circle, but
Isn't that a circle?
Hmm?
It'd be like,
yeah, but we're solving the equation, the system, right? Is that what you meant? Okay, that's fine. Okay, what do we do? I think I mentioned that to you. I created a file for each class that I teach. I created a file with all the links. So if you need this file at any point in time, it may not be 100%. I just saw an error here. Okay, so it may not be 100% spelled correctly, but I can send you the file with all the links for the entire semester if you're ever interested. Because I once I upload, I need to have it in, have everything in one spot. So I put it in the, so today is November 20th, right? So these would be the links for today. And in addition to that, I put it here as well for you. I don't remember who asked this for a friend from another class. She's taking another class. I don't remember. You did?
Yeah.
Did I send it to you?
She really liked it.
Okay, I'm very happy. Okay, I'm back. So what are we doing? Okay, we have that system. Sorry about the interruption. Well, in this case, I don't have the same variables. So I have no choice. I have to substitute. It doesn't matter because both have coefficient 1. It doesn't matter which one you substitute for. You choose. Y equals negative x plus 1. So now I have to replace this in here. So I have x squared plus negative x plus 1 squared equals 25. So if you need an update, I can send this file again to you, medicine. Do you go by medicine or medi? Either. Okay. Very good point. We cannot take the square root from a sum. So good that you mentioned that, please. So the square root of 4 plus 9 does not equal the square root of 4 plus the square root of 9. This is the square root of 13, and this is 2 plus 3. So they cannot be the same. I can break the radical only if I have a product or a ratio, not if I have a sum or a difference. If I had the square root of 4 times 9, absolutely. Oops. Or if I had the square root of 9 over this, absolutely. But not if I have sum or difference. So the only thing I can do is here, just take it slowly, square, x squared minus 2x plus 1, move 25, and try to solve. After I combine like terms, I get 2x squared minus 2x minus 24 equals 0, and I divide by 2. And I get x squared minus x minus 12 equals 0. And of course, I'm hoping for a quick resolution here. Because remember, we have 4 methods, right? Let me refresh your memory in preparation for the final. We have 4 different methods of solving quadratic equations. Factoring, this is the only one that may or may not work. Taking square roots, only in a specific situation when everything is squared, right? Squared on the left-hand side and a number on the other. Converting the square, never, unless we're forced to, in the quadratic formula. But here, you're right, x minus 4. Because I had negative x plus 1, and the middle term would be negative. That's okay. So the first term squared minus 2 times the first times the second, plus the second term squared. Okay, so then we have x equals 4 and x equals negative 3. And I have to go back to the substitution, which was y equals negative x plus 1. So therefore, when I plug in x equals 4, I get negative 3. When I plug in negative 3, I get 4. Nice. So 4 comma negative 3 and negative 3 comma 4 are solutions of this system of nonlinear equations. Questions? So this was test 3 review. Yes? Anything else?
Check it.
Yes. Yes, we should always go back and check it. Yes. Let's check. Back to the original problem. I check 4, negative 3. 4 minus 3 is 1. Yes. 4 squared, 16. 3 squared, 9. 16 plus 9, 25. The other one. The other one was negative 3, 4. Negative 4 is indeed 1, and negative 3 squared plus 4 squared is still 25. So yes for both.
How do you evaluate it?
Yes?
Number 22, factorial term.
Yes, so let's look at some factorials. Do you have a particular problem in mind, or should I make one up? Okay, so let's suppose I have 35 factorial over 30 factorial. You may be able to put in the calculator, or you may not. It may exceed the capacity of the calculator, so be careful. But I know that there is a way of simplifying this. And I know that the top is bigger than the denominator, so I'll leave the denominator alone, and I'll write 35, 34, 33, 32, 31, 30 factorial, and stop there because these two go away. So 5, 4, 3, 2, 1. So this is the number, which could be in the billions. I have no idea. So 35 times 34 times 33 times 32 and times 31. And I got, okay, I got 39,955,840. 38,955,840. Good. Anything else? Say it again.
What about the one like 22 where it's like a pretty big difference? So it's 40 factorial over 450.
I cannot do that by hand. There is nothing I can do. It has to be with the calculator. Let's take a look. Oops. We were on the calculator, right? What am I doing? Sorry.
I have a question like that on the top with a big number.
So, but you'll punch it in the calculator, no problem there. So you have 40, go to math, go to probabilities, and select 4. Math, probabilities, select 4, and divide by 450. Be very careful and read the number carefully. So this is 10 to the 45th power. It's a humongous number. So 1.8 times 10 to the 45th. I cannot even name that number. I don't even know what it looks like. So 1.8 times 10 to the 45th power. Next question. Anything else? Any other topic?
Oh, factorial expression. Valuing the factorial expression. That looks interesting.
Good. What is it?
I'm just looking at the 21, so I didn't do nope. So
What does 21 say?
it's 20. So 20 is n plus 1 factorial.
I'm going to change it into n plus 4 factorial over n minus 1 factorial. Which of these two is bigger? Right. So leave negative n minus 1 factorial alone. That's carved in stone. And what now?
You just use n plus 1.
Times n times n minus 1 factorial. Don't ask me to multiply those. I'm just going to write them like this. n plus 1, n plus 2, n plus 3, n plus 4. We went to extreme. You're not going to have something like this, so multiply. We just wanted to review this, right, and see what it is.
Can we do expressing a sum using some?
Yes. 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 Can I choose, or you want to choose?
You can choose.
So we're given the bunch of things, and we want to summarize it with a summation notation. Very good. Okay, I'm looking at the end of chapter 8. This is in chapter 8. There's a review here. So I don't know if we did this one, but I think we did. But anyway, so let's correct me if I'm wrong. 1/3 plus 2/4 plus 3/5 plus ... 3 dots exactly, 15 over 17, and we want the summation. Did we do this one? Okay. So I hope you agree that all terms are fractions, right? So then the general term has to have a fraction in it. So you want to use, let's say we want to use k. Say it again. Careful. So it's a good point. K must be from 1 to whatever, but it cannot be 1/3, it cannot be 1/2. It's an index. It has to be an integer, and actually a natural number between 1 and blah 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 you want. 1 and 500, 1 and 10, 1 and 15, 1 and 10 million, but it cannot be a fraction. Exactly to what? 1, 2, 3, 15. Good. So then what do I have at the top? K. What do I have in the denominator?
Oh, this is the cross.
Exactly. Thank you. Of course. So let's try. When k is 1, I get 1/3. When k is 2, I get 2/4. When k is 3, I get 3/5. When k is 15, I have 15 over 17. Well done. Is that okay?
But now, what if there's one that's like similar to the 21, where it's
Which 21? Oh, from the. Okay. So what is the?
it's 1 plus 30 plus 5.
Right, but here you have already, everything is given, so you just have to have k equals 1 through n, and from 2k minus 1. Because you're given the general term. You don't have to determine the general term. That is already given to you. You just have to use the index. Is that clear? Better?
Yeah.
Okay, 5 minutes. What other topics we want to go back to?
Can we do a Gaussian Jordan?
Yes, of course. Of course, with pleasure. Do you have one, or do I have to choose one? We may not be able to finish it in 5 minutes, but we'll try. You want me to choose? Yes,
I'll just give you the matrix.
yes.
1, I'm going across. 1, negative 3, 0, negative 22, 5, 1, 5, 5. 2, negative 3, 4, negative.
Perfect. Okay, so start without me. I have to dig deep for more paper. They ate up all my paper. Not at all. Here it is. Okay, so obviously we will have to multiply row 1, negative 5, and row 1 again. Excellent. We copy the first row as 1, negative 3, 0, negative 22. And now careful. 1 times negative 5 plus 5. Negative 3 times negative 5 is 15 plus 1, 16. 0 times negative 5 is 0 plus 5 is 5. Ugly. So negative 22 times negative 5 is 110. 110 plus 5 is 115. Next one, 1 times negative 2 plus 2. Positive 6 minus 3, 3. 0 plus 4, 4. 44 minus 1, 43. What I would have done, but again, I don't want to get into, to get too sophisticated. This was what I would have done. I would have multiplied row 3 by negative 5 and added to row 2. I can do that, and I would have created the 1 in here. Otherwise, I have to divide both sides, I mean the entire row, by 16. Since we're here, since we want to finish it up, allow me to do that. So I'll multiply row 3 by negative 5 and add it to row 2. 1, negative 3, 0, negative 22, 0, 3, 4, and 43. Negative 5 times 3 is negative 15 plus 16, 1. 4 times negative 5 is negative 20 plus 5, 15, negative 15. Now this, negative 210 plus 115 is 100, negative. So yes, that was an artificial kind of step. Not so artificial, but we didn't get into so many details of how to manipulate these equations. So I multiplied row 3 by negative 5 and added to row 2 just because I wanted to get that 1 without having to worry about a fraction. So then now this is already done. So I want to multiply row 2 by positive 3 and add it to row 1, and row 2 by negative 3 and add it to row 3. So I copy row 2, of course. So in this case, I avoided, by doing that, I avoided having to work with a fraction. So 1 times positive 3 minus 3. Negative 15 times 3 is negative 45. Negative 300 minus 22. Positive 3 minus 3. and this is 45 plus 449, and negative 126 minus 100, negative 226. Obviously, I'm hoping that I can divide 226 by 49, because otherwise it's not divisible.
Oh, wait, wait, wait.
226 divided by 49. Okay, so in that case, I have to go back and check. I have to check, first of all, whether we copied the matrix correctly. That's my first step. Since it's 6:20, we can stop and we can finish this, some other time. But I will finish it up right now. But you don't have to stay. It's up to you. So, Becca, can you make sure that it's 1, negative 3, 0, negative 22? Is it 5, 1, 5, 5? And 2, negative 3, 4, negative 1? Okay. So then we multiply by negative 5. This was indeed 15 plus 1, 16. This is 0 plus 5, 5. This is it is 110, positive 110, plus 5, 115. Okay. Times negative 2, yes. So this is 6 minus 3, it is 3. This is 0 and 4. And this is 44 minus 1, which is 43. Okay, one more time here. Negative 5. It doesn't have to give us integers, but I'm just checking my numbers here. So negative 15 plus this will be 1. Negative 20 plus 5, negative 15. What did I get here? Is this correct? Yeah, so minus 210. Yes, plus 115. Ah! One more time. Negative 15. Negative, so this is negative 215. But plus 215, so this is 100. What did I do? One more time. So this was 115 initially, so it's a minus 100, right? So R3 times negative 5 is this, but plus 115 is negative 100, right?
You have to put the matrix down. You did it.
Oh, yeah, I'm checking there, but I'm sorry. That's what happens when you start rushing. Yes, I'm okay. So yes, this is negative 100. I'm fine. Okay, so now it was okay. One more time. Negative 20. Yes, that's correct. And that is negative 100. Good. So that's fine. And now I'm trying to eliminate the negative 3 and the 3. Right? Multiplying by 3. This is negative 45 plus 0. This is negative 300 minus 22. Now this is negative, so it's 0. This is indeed 45, correct? Plus 4 is 49. Now let's check the last one. So negative 3, so this is 300. Oh, okay, so I see the mistake. So negative 300, but plus 43. I don't know how I came up with that. Where does that come from? So negative, one more time, right? So negative, so it's 300 plus 43, 343. Okay, now 343 divided by 49. We can always check. We always check at the end, right? So we know.
7.
Okay, that's much better. Okay. I don't know how I came up with that number. So we'll divide row 3 by 7. So 1, 0, negative 45, negative 322 by 49. You're right, of course. And we get 7, 0, 0, 1, and negative 15 and negative 100. Okay, and in the end we always check, right? So multiply row 3 by 45 and add it to row 1, and row 3 by 15 and add it to row 2. And this should be the final answer. Okay. So indeed, 1 times 45 plus 45 has to be 0. 7 times 45. Can anyone help me with 7 times 45 minus 322?
Negative 7.
-7. Okay. And finally, so times 15. Negative 1500. I'm rushing. Okay, so 15. Okay, that's okay. 7 times 15 and minus 100. Positive? Okay, so it appears that the solution is negative 757. And remember what I showed you last time?